Hello and welcome to Tech Explorer. I hope you all are doing well. So today in this video, we are going to see how do NumPy array mathematics work. If you are new to NumPy array and want to know more about these n-dimensional arrays, then do watch my earlier video, An Essential Guide to Python NumPy. I will share the link in the description box below. Here in this video, we are going to deal with all the major functions that we can use to do mathematics with arrays. I will explain each of those functions and their working step by step with simple lines of code. Excited? So let's do some maths with ND arrays. So to begin with, let's take up the add function. So the NumPy add operation is used when we want to compute the addition of the two arrays. It adds arguments element-wise. If shape of two arrays are not same, they must be broadcastable to a common shape, which may be the shape of one or the other. I will cover broadcasting in my next video. So now let's understand how this add function works through some simple lines of code. So in the very beginning, we import NumPy as np. This will import the NumPy package, and you can use anywhere in the code NumPy with the alternative name as np. So first we create an array, array1, by calling the np.array function and passing two arrays to it. So this is going to create a two-dimensional array in a 2x3 format, that is 2 rows and 3 columns. Now we create similarly a second array by calling the function np.array and passing two arrays to it. So here it also will create a two-dimensional array in a 2x3 format. Now we want to add this array1 and array2 by using the np.add function. So we call np.add function and we pass these two arrays as its argument. So when we print this third array, we are going to get an array where every element will be the sum of the corresponding elements at the same position of the two arrays which we wish to add. So here, for example, let's see what is the first element of array1. That is the element of the first row, first column. That is 1. Now the first element of array 2, that is first row, first column element, is 4. So when we add up this 2, we get 5. So 5 becomes the first element of the new array, that is the third array. Similarly, let's consider the second element, that is the first row, second column element of first array, array 1, that is 2. So similarly, the array 2 element, second element of array 2, that is 5. When we add these two elements, we get 7. So this addition goes forth. Now we can use the plus operator also as a shorthand instead of calling np.add. So we can also say array equal to array1 plus array2 for addition of these two arrays. Now let's see the subtract function. So NumPy subtract function is used when we want to compute the difference of two arrays. It returns the difference of array1 and array2 element-wise. So let's see with some simple lines of code. So as earlier, we import NumPy package as np. Then we create two arrays by calling the NumPy's array function and passing two arrays, which will create a two-dimensional array in a 2x3 format. Similarly, we create array 2 by calling np.array and passing two arrays, and this will create a two-dimensional array in a 2x3 format. Now we want to subtract these two arrays. We want to find out the difference. We call np.subtract function and pass these two arrays as its argument. So when we print this array, we are going to get the difference of each element at the corresponding position of the two arrays which we want to subtract. So again here, if we see the first element, that is the element in the first row, first column of array 1, that is 1, and the first element of array 2, that is the element in the first row, first column, that is 4. So when we do 1 minus 4, we get minus 3. So this becomes the first element of the array 3. That is the new array. Similarly, the subtraction takes place. So instead of calling np.subtract function, we can also use a shorthand minus operator to do the subtraction or finding out the difference between the two arrays. Now let's see the multiply function. The multiply function is used when we want to compute the multiplication of two arrays. It returns the product of array 1 and array 2 element-wise. So let's see with the lines of code. First of all, we import numpy as np. Then we create the first array by calling the np.array function. This is going to create a two-dimensional array in a 2x3 format. Then we create our second array, that is array 2, by again calling the np.array function. And when we print this, we are going to see the contents of a two-dimensional array in a 2x3 format. Now we want to multiply this 2 array. So we call np.multiply function and then we pass these two arrays as its argument, that is array 1 and array 2. Here we are going to create a third array where each element will be the product of the corresponding elements at the same position of the two arrays which we want to multiply. So as you can see, the first element of array 1 is 1 and the first element of array 2 is 4. So we get the product as 4, which becomes the first element of the new array. So henceforth this multiplication takes place. So np.multiply function can't be applied on arrays with different shapes. This thing has to be noted. So if shapes are different, they must be broadcastable to common shape, which may be the shape of one or the other. Now let's see the numpy's divide function. The divide function will return a true division of the inputs element-wise. Instead of Python's traditional float division, this returns a true division. The true division always tries to produce a true floating point result. It does this even when the two operands are integers. All other operators, they try to preserve the type of the data, but this true division operation, when applied to integers, it produces a float result. Now let's see the code. We import numpy as np. We create our very first array, array 1, by calling numpy's array function and passing arrays to it. This will create our 2D array in a 2x3 format. Then we create our next array, that is array 2, by again calling the np's array function and passing the arrays to it. This is also creating a two-dimensional array in a 2x3 format. Now we want to divide these two arrays, so we call numpy's divide function and pass the array 1 and array 2 as its argument. So this will create a third array where each element will be the true division of the corresponding elements at the same position of the two arrays we wish to divide. So here we are going to get the result. So the first element of array 1 is 4 and the first element of array 2 is 2. So when we divide this, we get the true division value, that is 2 in floating point. Now we can also use a shorthand operator for this np.divide function. Instead of calling np.divide, we can use a slash operator. So this true division, it adjusts the output type to present the best answer regardless of the input types. Now let's see the numpy's remainder function. So it is another function for doing mathematical operations in NumPy. It returns element-wise remainder of division between two arrays, array 1 and array 2. So let's understand by the simple lines of code. First we import numpy as np. Then we create our first array, array 1, by calling np.array function and passing two arrays to it. This is going to create a two-dimensional array in a 2x3 format. Then we create our second array, that is array 2, by calling np.array and passing arrays to it. This is going to create another two-dimensional array in a 2x3 format. Now we call np.remainder function and then we pass array 1 and array 2 as its argument. So this will create a third array where each element will be the remainder of the corresponding elements at the same position of the two arrays, which we are passing as argument to the remainder function. So this remainder function is also producing the same result as np.mod function. Now the np.power is a mathematical function in Python that is used to get one array that contains the elements of the first array raised to the power element of the second array. The numpy power function takes two main arguments, the array of base and the array of exponent, and returns the array with elements of the first array raised to the power element of the second array. This means if we have two arrays, for example, and both should be of the same size, array 1 and array 2, then numpy.power will calculate array 1, ith element of array 1 raised to the power ith element of array 2 for each I is equal to 0 to the size of the array minus 1. And if values of array 2 are not positive, then this function will return a value error. Now let's see through simple lines of code. We import numpy as np. We create our first array by calling np.array function. This will create a two-dimensional array in a 2x3 format. We create our second array by calling np.array function. This will also create a two-dimensional array in a 2x3 format. Now we call np.power function and then we pass this array 1 and array 2 as its argument. So here in this example, the very first element of array 1 is 1 and the very first element of array 2 is 4. So we are going to get the result as 1 raised to the power 4. That is 1. Similarly, if we consider the second element of array 1, that is 2, and the second element of array 2, that is 5, so 2 raised to the power 5 will give 32. So henceforth, this power function will work. Now we see the numpy square root function. So numpy square root function is used to determine the positive square root of an array element-wise. Now let's see the lines of code. We import numpy as np. We create our first array by using numpy's array function and pass arrays to it. This will create a two-dimensional array in a 2x3 format. Now, if we want to find out the square root of each of the elements of the array, we call the np.square root function and pass array 1 to it as an argument. So here you can see the square root values of each of the elements of array 1. Now let's have a look at numpy's sine function. So this mathematical function helps user to calculate the trigonometric sine for all the elements of an array. So first we import numpy as np, we create our first array, then we call the numpy sine function and then we pass the array 1 to it as an argument. So we are going to get the trigonometric sine values for all the elements of the array passed. So the trigonometric functions of numpy help to solve the mathematical trigonometric calculations in an efficient manner. The numpy sine function helps to find the sine value of the angle in degrees and radians. Now we come to numpy's cos function. So this mathematical function helps the user to calculate the trigonometric cosine for all the array elements. We import numpy as np. We create our array 1 by calling the np.array function and then we call the np.cos function and pass array 1. So this is going to calculate the trigonometric cosine values of all the array elements. Now we come to numpy's log function. So it's a mathematical function that helps the user to calculate the natural logarithm of x, where x belongs to all the input array elements. So here we import numpy as np, we create our first array, then we call np.log and we pass the array as its argument. We are going to get the log values, logarithmic values. The numpy module of Python provides a function to perform the dot product of two arrays. If, for example, the two arrays is a zero-dimensional scalar array, the dot product will perform multiplication. If both the arrays, array 1 and array 2, are one-dimensional array, the dot function will perform the inner product of vectors. If both the arrays, array 1 and array 2, are two-dimensional arrays, the dot function will perform the matrix multiplication. If suppose array 1 is n-dimensional array and array 2 is a one-dimensional array, then the dot function will perform the sum product over the last axis of both the arrays. If suppose the array 1 is m-dimensional array and array 2 is n-dimensional array, where n is greater than 2, then the dot function will perform the sum product over the last axis of array 1 and the second last axis of array 2. So here in this example, if we see the dot product, how it is calculated. The first element of the new array that is created after the dot product of array 1 and array 2, that is 37. It's calculated by taking the first row of array 1 and the first column of array 2. Then a sum product is performed. That is 1 multiplied by 11 plus 2 into 13. We get 37. And so on, the calculations are performed. Now let's check out some of the aggregate functions of NumPy. So the very first function is the sum function. It will calculate the sum of all the elements of the array. The min function will calculate the minimum value among the array elements. Similarly, the max function will calculate the maximum value among all the array elements. The cumsum function will calculate the cumulative sum of the array elements. The mean function will calculate the mean value of all the array elements. The median function is going to calculate the median, and the std function will calculate the standard deviation. We have to create our array, and then we have to pass our array as an argument in these functions for getting our desired results. Now let's see the operators for comparing two arrays. So we can use equal to, greater than, or less than operator. So these comparisons are done element-wise, and when the condition satisfies, it returns a true, else a false is returned. So this was all about the functions for doing mathematical operations in NumPy. If you have any doubt, query, do let me know through the commenting below. Do like and subscribe my channel for more tutorials. Till then, stay safe, stay healthy. Thank you.